So, time to start. Hello, everyone. I'm glad to be here again in Krakow. I love the history. I love the place, especially the medieval wars that we had. Such a beautiful history. And I love everything around Krakow, especially the weather for this week. So today is not to talk about Krakow and Poland, unfortunately. Let's talk a little bit more about software engineering, software development, and I will cover why persistence layer can be much easier using a specification. So I will cover the Jakarta Data specification for us, because the main goal for me and to the members of the Jakarta EE community is to make the life easier for us Java developers, because we love simplicity, okay? Before I start, as usual, I love history, philosophy, and to answer the question, why do we care about database nowadays? Why database is important to us? And to put it simple, database is not about us as software engineer. We're talking about the humankind, because the database is to endure knowledge through the generations. We started doing that with temples, caves, libraries, and finally we can do it with distributed database, okay? So it's about retrieve, delete, update, and handle with information. And based on that, with the time, we achieve more efficient way to handle and store information. That's right now we do have the philosophy of polyglot persistence. And what does that mean? The idea of polyglot persistence is to achieve the adaptability of a database inside our software architecture. So, Otavio, what does that mean? Take, for example, people who can speak more than one language, like 4, like 5. This person can adapt in several different places. So take, for example, a person who can speak Spanish, English, Italian, Portuguese, and French. This person can go to Brazil, to France, to Spain, to Latin America, and to the majority of the countries if without any issue. Okay, no pause today. I'm kidding. I need to do this. Perfect. Oh, thank you. So, so how about the polyglot persistence? It's exactly the same idea. It's the idea to adapt my software architecture to everything that makes sense for me based on my context. So I don't need to use only relational database anymore. I'm not saying that the relational database is deprecated. It's still super important. It's still super crucial. But if you only know a single tool, you're going to use a solution for everything. Remember the instrument law by, I forget his name right now, the Marshall law, that if you only know the hammer, everything becomes a nail. And it is not okay when you talk about software architecture, right? And that is the main idea of the polyglot persistence, to be capable to adapt in several environments and contexts using and exploring different databases. So, relational database, NoSQL database. I won't cover the tip today because Max and Gustavo will cover that on Friday, okay? So we do have the classic one and then several flavors. Those one here is important to say are only the most common NoSQL database types. So wide column, graph, document, and key value. However, we have much more implementations. Right now, I guess we do have over 200 NoSQL database. It's a huge amount. Okay, right now I explain about persistence layer, database, polyglot persistence, and let's talk about the biggest war that we are facing every single day inside our organization. Of course, I'm talking about the fight between developers and DBAs, the application against the database, especially because those are speaking different language. those belongs to different paradigms. Take here, for example, I do have my Java application, then I do have my person, an address, a list of address, as you can see here, and then, as usual, I do have my relation database. As you can see here, I have 3 tables to represent 2 instances and a list. So because I cannot speak inheritance inside my database, I cannot speak polymorphism, encapsulation, and different types because those belongs to my language. And on the other hand, inside my database, my language will not understand normalization, denormalization, and different kind of structures because those belongs to the database. So how can I make it more easier and super efficient to handle with that? Of course, one way to make it possible is using what we already have. In this case, these database patterns to make this integration good and fast as possible. Take here, for example, I will list only 6 database patterns. Of course, I won't have time to cover one by one, especially because my main goal is to introduce the new specification. But as you can see here, those are common between database or among database. It doesn't matter if you're going to use SQL or NoSQL database. So driver, this one is close to the database. Data mapper, this one going to translate between database and my application. Data access object, so the layer to do the communication between your application and your database. Active records, an entity with superpower, so this entity can handle and do database operation. Repository, a domain-centric way to handle with DDD by Eric Evans. And finally, the data transfer object. So using these 6 patterns, you can make your life easier. It doesn't matter if you're going to use NoSQL database or relational database. And with those patterns, one thing that you need to put in our mind is the style of this program language. I mean, if you go close to the database, you might doing some data-oriented programming. And on the other hand, if you go close to the application, of course, I will explore more object-oriented programming. So a driver naturally is closer to the database. Repository is closer to the application. To speak quickly about those approaches, I do have the one super close to the database that expose more data. The good idea here is to expose data and don't care about behavior. And then represent data with generic data structure. And finally, treating this structure as immutable. And on the other hand, probably you are familiar with the clean code by Uncle Bob, where in the chapter number 6, if I do have a good memory, he explains around objects. And to him, the main approach of objects, or the main goal of objects, is exactly to expose behavior to hide data. So we have 2 different approaches, different from each other. And then we do have abstractions, polymorphisms, and so on. Okay, after introducing you the idea of database, the idea of polyglot persistence, where you can use, yes, multiple database based on the context inside my software architecture, let me introduce you a new specification that's going to make your life easier cross database. That is the Jakarta Data. The main goal of Jakarta Data is, of course, you as a developer can work as usual with doing your codes, make your life easier and happy. And then you can ask yourself, what kind of database do I need to use? If you're going to use a relational database, that is naturally Jakarta Persistence, former Jakarta JPA. And on the other hand, Jakarta NoSQL. And finally, one layer that can communicate with both specification, that is Jakarta Data. So right now, the main goal of Jakarta Data is to introduce to you several database patterns that is common amongst database. It doesn't matter if I do have NoSQL, SQL, or maybe NewSQL. Okay? On this first release, naturally, it's impossible to cover everything in the version 1.0. We're going to cover only a single pattern, that is the repository one. But before I explain what repository is, I need to explain you what is a repository for us and the components inside Jakarta Data. So basically, we do have two approaches inside Jakarta Data. The first one is my entity. By the way, who is familiar with JPA or Jakarta Persistence? So I guess almost everybody. It's basically one class, one single class with annotations that has one ID. So that's my entity. And then I do have my repository. That basically is the operation layer that will work close to my business, being super domain-centric way. So as I explained to you, I do have my entity, my product. As you can see here, my annotation, my ID, and so on. So based on that, I can work with either Jakarta Persistence to relational database or Jakarta NoSQL to NoSQL database. And then we do have the approach of repository. If you are familiar with Spring, you might know that looks like pretty similar as we do have in Spring. Indeed, the main goal of specification is standardize what we do have in common and make it more accessible for everybody. And that's what we did. So we do have the product interface, and this interface here will operate and do a single of or a lot of operations. For example, here, I'm deleting by the ID. So I'm doing the method by query. So I do have my prefix, I do have my condition, and then my operation. So take here, for example, I'm doing the find by name, contents, and price less than. So what I'm doing the query by methods. So I'm executing a query basically on the name of the method convention. The first step, or the first part of this method, is about the query action. So I'm doing a retrieve information. I'm doing find by. Then I'm doing the attribute of the entity, then the conditions, and finally the second part where I'm taking the price and then the conditions less than. So, and then I put two parameters. So the pattern of name and then the price where I'm using float for some random reason. So don't ask me why. And as you can see, if you ask you each database I am using, you have no idea, right? I can use any database because the repository belongs to the database itself. It's a pattern to database. This way, I can use NoSQL, I can use SQL, I can use whatever I want, and my clients or the people who are gonna use my code has no idea exactly about the database that I'm using. So might be SQL, might be NoSQL, or might be a new conversion of database. So here is a sample of serialization. So we do have the entities using Jakarta persistence annotations. Then we do have the Jakarta data provider that naturally will communicate with JPA or Jakarta persistence, do the transition to JDBC, and finally convert that to my tables. So nothing different that we do or usually handle with nowadays. And then we do have our NoSQL database. Each, I'm using entities, then my provider. And this time, instead of use JPA or JDBC, I'm going to use the driver or the NoSQL driver. In this case, I'm using, for example, Eclipse NoSQL implementation of Jakarta Data. So it will convert instead of table to a document, because in this sample here, I'm using document database. What matters for us is I can use for a particular behavior, and finally, I can extend this interface. This way, I have more capabilities, and more capabilities that may vary by the vendor or this database type. Take here, for example, I do have the data repository. It is the father, it's like the object for repository. Then I do have the basic repository to handle with basic operations like save, like find by ID, delete by ID, and so on. And finally, I do have my pageable repository and my CRUD repository. And as you can see, CRUD repository is one specialization of a basic repository that can do a little bit more things. For example, create and insert and update methods inside this kind of repository. And if you wish, you can go beyond. You can take particular behaviors of this database. Take, for example, here, I'm using the AroundDB repository. That is a specialization of NoSQL repository. That is a specialization of pageable repository. And something happened with MongoDB, with Couchbase repository, and so on. The point here is I can make my life easier, and if I wish to use some particular behavior, I can do have repository specializations for. Okay? So to make it, to simplify a little bit, please allow me to show a little bit of code. So, no, you. So to make my life easier, of course, I'm going to run with a snapshot version. Why not? I'm going to use data faker because I will generate a lot of data. It's a simple Maven project, as you can see, with two dependencies. One is Eclipse NoSQL MongoDB, and the second one is data faker, where I already have my entity. If you remember, my entity basically is a class with a couple of annotations that defines, and also a unique identifier. In this case, once I'm using Eclipse NoSQL, I can have an immutable entity. This way, I can use entity with records. Probably there is nothing new for you. Beyond that, what I do have, I have my beer, and I will generate several beers based on that. So I have my beer, my class, anything normal here. I do have my application that will start my Java SE container. So if you're not familiar with CDI, after the 2.0 version, you can use CDI on Java SE. So that's exactly what I'm doing. But remember, everything that I'm doing with this Java SE standard edition, I can run with microprofile, and I can run with Jakarta EE. So I do have my beer, I do have my annotations, I do have my fields, and my next step is, guess what? Create my repository, and that's exactly what I'm gonna do. So I will come here, I will, pray to its work right now, and then I will create my beer repository. That should be an interface, naturally. And then I will extend like I usually do with Spring, right? I mean, who is familiar with Spring Data? Okay, I feel at home right now. So right now, I will do pretty similar thing. So I come here, I will create my basic repository. I have two parameters, And you probably know, right, what does these parameters means. So the first one is my entity type, in this case, my beer. And the second one is my ID and my ID type, in this case, the string. So I come here, and I do have those parameters. And I need to identify this repository as repository to Jakarta ecosystem. So I do have my repository. I have my app. I'm created the faker interface here, as you can see. The next step is create my, oh, thank you. I love Copilot. Sometimes it gives a good, save me a lot of time. So what I'm doing here, I'm injecting my beer repository, and based on that, I can create new instance. So the first step that I'm gonna do, I will execute with empty database. So let's do it first. I will come here. So search, executing, find all. And then I come here, no you, repository, find all. For each system, out, print ln. So I will come here and execute. I check the Docker a couple of times. Hopefully it's going to work. So I'm executing. And of course, because there's nothing to show. But my next step here is to include at least 100 beers or different beers. So I come here. I have my faker. I will do my for each interaction. So for each, I will use index. I come here. So I will create my beer. Thank you, Copilot. Thank you again, Copilot. So I will create my beer and then save my beer. And naturally, when I execute again, it should show all the results that I do have. So as you can see here, right now, I do have 100 beers. So with different styles, with different hop, with different malt, and so on. And I can do a couple of operations based on that repository. So if I come here and click on my basic repository, I do have a couple of methods, each I don't need to implement by myself. This provider will convert that information for me naturally. And again, I'm talking about cross-database. I do have this implementation for relational database. For example, Hibernate is working on that right now. We're going to have OpenLiberty working on that right now. And for NoSQL, we have at least Eclipse GeneSQL make it possible. So with this repository, I can use for both. I can use for SQL and NoSQL. And that is my first step. Naturally, you can do queries, right? I mean, if you are familiar with Spring Data, you might know the method by query thing. So where I will come here, I do my beer, and then I do find by my condition, and then my operation. So find by style. So I will do a query find by style. Let me take at least one style here. So I take block. And then I will remove this code here just to make my life easier. And I will do the repository find by style where it is block, and then do the for each with system print ln. So I come here, the query find by style. And then I will execute again. This time, I will only search for the book style. Okay? So you know that. You are pretty familiar with that. So there's nothing new if you come, for example, from a Spring Data. Beyond that, we do have two different ways to do query using Jakarta Data. The first one is using a annotation. So take for here, for example, I can copy and paste naturally, do a style, and then I do have what we call actions annotations, where I can do a couple of operations based on that annotation. That means I can create my actions super domain-centric and make my life easier. Take here, for example, I can come here. I do have the method find, and then I will put the by style, and I will have the same behavior. And naturally, imagine right now that you want to write some methods using ambiguous language. For example, imagine that every time that my business say beer or drink a beer, it means delete the beer from my repository. So what you can do, you can come here, you can use drink, you can have a beer, and finally come here, use the delete method operation. This way, the specification will understand that this drink means that you have one drink left inside your repository. Think about more actions. So imagine the opposite. So if I do the drink, that means I will do an insert operation, or I will do the update operation. And of course, I can do the save operation that will work nearby what you do have with the save method. So what does that mean? If I use the insert, it will check if the information is there. If it's there, it's going to throw an exception because it should not be there. If it's update, I need to check if the information is there. If it's there, I will update the information. Using save, the whole abstraction belongs to the provider. That means if the information is there, it will update. If the information is not there, it will insert for you. So it's up to you to choose those operations. So let's delete this guy a little bit here. So I return. This time I'm going to use the style. And then I will execute the query again. So right now I still have the style block, right? But imagine right now that I want to sort by hop. So right now it's returned the result, but I'm not happy with that. So what can I do? There is two ways to make it possible. Using find, you can combine this annotation with another annotation. For example, sort. So I can come here. I can use, order by. I can define style, but this style is the one that I'm looking for right now. So I will use the hop, another field of my beer. So I come here, I will find by block style, and then order by hop. Let's execute again. This time, the block with the hop amarillo, you'll be the first one. And the vanguard hop, you'll be the last one. Of course, you can do the opposite here. So I can do the descending true. This way, I can execute, and amarillo gonna be the last one. And then the one that was the last become the first. Everything using database, using operation, using notation. And my question remains, what database I'm using right now? As a client, you have no idea, right? So I can use, for example, SQL, NoSQL, and it's NoSQL word, I can use document. I can use with MongoDB. I can use document with Arango. I can use document with Oracle, NoSQL, and so on. So you can use based on these patterns to make your life really, really easy this way. So I cover this couple notation. Right now, please allow me to do one more step, that is pagination, okay? So I will come here. I do the query by name. Oh yeah, there's one way that I forgot. You can do the query. In this query is Jakarta query language. Okay? This one is a partial part or a subsistence of JPQL. That means if you know JPA, you might be super familiar with what you're doing right now. So I come here. I will define this one here with params. And then I will execute query. That belongs to my GPQL. And of course, we love syntax sugar, right? And the question is, if I want to return my beer, why should I use select star? So can I remove this? Yes, you can. So right now, I do have my from, beer, or my style is the style that we will define. So let's remove the typo here. And let's remove and execute the query and pray to the gods of demo to make it work right now. So right now, I do have my query by Jakarta Data query language. Of course, you can define the order. So order by hop descending. So when I execute again, oops, descending, something goes wrong. Let's see what's going on. Where order by? Let's try a new one here. If not, trust me, it's working production. So it's working Amarillo, Bravo, Ultra, Vanguard, and so on. So right now, I can do queries use Jakarta Data query language as well. Okay? Those are the ways that I can do query. Repeating the method by query, for who is familiar with Spring Data. I can do using the match parameters. So one parameter, one field, one attribute, as I'm doing here. With the find annotation, I can combine that with the order. And the last one is naturally the query by Jakarta Data query language that is a subset of JPQL, so Jakarta Persistence Language something. So I'll come here. Right now, what I'm going to do is, I still have 16 minutes, I will explore and then finish 2 ways of pagination. I guess the first one, the majority of you already know, is the offset way. So I will come here. I will create my page request. And then what can I do? I will define the page and then the size. So the main difference that we do have of Spring is Spring have a page request that does the pagination, the order, and so on. In the specification, we decided to have 2 different objects because of the single of responsibility of this object. So we do have the page request, come on, and then we do have the order. So the order where you can define the order that you want. Okay? So I will define the order here. And then I have my order, come on, by now you hop. So I have my pagination, I have my order, and finally I can run my page. So I will come here, I have my repository, no you, but you, and I can do a find all with the pagination. So I will run my first page, and then naturally I can take my, no, let's do a little bit different here. So I have my var as a page. So I have my page here, and then I can have my next page. So next page request, next page request, and finally I can do again with next page and do the query again. So let's put some logs here. So now you, page, first page, thank you, and then next page. And I will execute again. So also I'm using the order by hop, so it gets this information, and naturally I can run with the pagination side, with the pagination number. However, remember, offset is one way to handle with pagination. Okay? We do have another way that instead of doing a skip of my query, because basically, if you're not familiar with pagination offset, basically what I'm doing here in my second request is I'm doing a linear query execution, and then skip 2 values, and then take the next ones. So it's not efficient because I need to run the query in the linear way. So imagine, for example, if I do have 1 million of rows or documents, I need to run the 1 million rows, skip the majorities, and then take the ones that I want skip. That is also the cursor pagination, where I can do the pagination by cursor. That works like a pointer. So as you can see here, my first page is Antun, Antahu, and Dark Ladder, and Fruit Beer. So I take here, I will create a next one that will work almost the same as this one. But instead of using page or list, I'm going to use my cursor page. This way, it's going to work for me as a pointer. So I come here. I will include a new parameter that is naturally the page request. So I come here. I'll remove this guy a little here. So I have my cursor, I have my style, I have my page request, and then what I'm going to do next is to create my second style of pagination, the cursor pagination. And then, based on this cursor, what can I do is I come here, I will do my first query as cursor, no you, but let's remember the method name. I will let's use cursor to make my life easier. So let's use something like this. So page, I will ignore a little bit. Let's use the size of 2. And then ignore this parameter here. So I will take one style. So let's use the dark larger one. So I take the first one, cursor. Let's use this cursor page here. And naturally, it is a specialization of page requests or page. This way, you can do almost something. However, I can come here, my cursor for it. And then one thing that I do have here, cursor, next request. So next. And this one here has a pointer, as I mentioned to you. So I come here. So now you again. Next. Cursor, OS throw, get. So you can see my pointer. And then I will execute again, this time with a next page. So I come here as a next. And then I will execute again. So I'm using a not good ID cursor. So on this case, my recommendation for you, if you're going to use a cursor, make sure that the order going to use something that's unique, like an ID, or you can combine multiple fields. On this case, for make my life easier, naturally, I'm going to use the ID. So let's come here. So I have my cursor page here, cursor pagination. Then, as you can see, my cursor has one pointer that is my ID, of course, and is exactly what I do have in my previous element. This way, I will find after that in my query. So with offset, I need to run and skip in the database. With cursor, I have more efficient way using this as a pointer. What matters is we do have two ways to handle with pagination with Jakarta Data. And that is all. So, of course, we do have a huge universe of persistence layer, Jakarta Data, and so on, that is impossible to cover in only 50 minutes, 45 minutes to be more precise. But that is configurations, cloud, cache, connection pool, data manipulations, data migrations, cloud, environments, Jakarta Data, Jakarta NoSQL, and so on. And for make my life easier and your life easier as well, I wrote a book where I cover the whole topic details around Jakarta persistence and to make your life efficient using, doesn't matter, relational or no relational database. So that's all for today. I hope you enjoy and thank you. So the next step is, let's go to the questions. So are there specification class present in Jakarta Data to build dynamic queries? We don't have this feature yet, but it might come to the next version. Remember, our first release goes to integrate with repository. Others method, okay. Does Jakarta Data map directly to Spring Data repository, or is there something we should watch for when we migrate? The goal is to have a silly and simple migration where we do have the Hibernate team work on that right now. So the idea is, yes, you can use Spring Data if you wish, but if you want to use the Hibernate solutions, you can do it without multiple problems. If we define a complex SQL query, it will work properly with MongoDB, for example. Naturally, as I mentioned, Jakarta Data Query Language is a subset of JPQL because there are several capabilities that work with relational database, but it won't work with NoSQL database. And of course, every time that we talk about NoSQL database, we talk about we cannot do joins. So joins, will work only with relational database. Are those methods in repository interface transactional? No. It is super stateful. This way, it doesn't matter if you do have some lace annotation. By specification, you need to return as eager. This way, you won't have any lace exception anymore using Jakarta Data. Is there any equivalent for data JPA test here? Yes, it does. It's called Hibernate. So it's super popular nowadays. They're implementing right now, they're running the TCK, so everything is fine. And each type of application does the developer know or care about the type of persistent system used? It's a good question. I can say that if you're going to use DDD, for example, I'll not say that you should not care about the database, but on that layer with the business, we want you to write ambiguous language. This way, you want to write your code close to the business as much as possible. Of course, once you choose, and for a NoSQL database, for example, Cassandra, you need to take advantage of that. You need to go to run and explore consistency level, Cassandra query language, and so on. What I meant about doing that is you can write a domain-centric language to your business. So, for example, imagine that I do have a car as empty, and you do have a garage as repository. You can define that parking is one way to insert information, and unparking is one way to delete the information. So you don't need to use the insert and update anymore. You can use your ambiguous language plus the actions annotations to make it super close to the business. That's my point. How do you test your repository in a unit test? How can the annotation be evaluated for tests? You can use that with, as you do with Hibernate. So you can run with integration tests, exploring test container if you wish. Spring Data provides something pretty similar, so it's not a rush. Remember, we're going to release this version on July. We're going to increase our environment that includes more tools, integration tools. We are working together, for example, with IntelliJ to make our life easier. So you are capable to do the queries with control space or command space if without any problem. But right now, you can combine test container with your database and initialize your Jakarta Data provider application. Beginning, you talk about polyglot persistence. What is the best way to make one? Having two databases in the same project or in separate projects. So the first thing about polyglot persistence is not about how, but why. Why should I have two databases in a single project? The point here is understand when and why you're using this kind of thing. For example, if I want to use and explore fraud detection, it might be super valid to use graph database. If I want to work with database that handle more with eventual consistency against eventual persistence against the strong consistency, you can handle with Cassandra and so on. So it's more about why. Of course, you can combine, but usually what we do is every application with at least a single database. It's not natural to have one application with two databases unless you are doing the migration. You are doing the legacy migration with that. That's all for today. Thank you. And remember, I have 2 books and 1 socks. So you can come here for the people who ask the question and take it. Thank you again.